Good afternoon, everyone. Today, our lecture will be on the interesting topic. This interesting topic will be the BJT. What does mean? That means bipolar junction transistor. Let's go to the next slide. I push here or here. Where is the next slide? A bipolar junction transistor. And these few pictures illustrate to us we're talking about what and why this topic is so some rare to us, why we interesting, what the relation with us with this device like that. Let's imagine why this device has three legs, what the similarity with the Schottky diode, what the difference between this topic and Schottky diode, how we can benefit, when we can use it, where we can use it, and let's talk and try to solve some questions, important questions actually related with this topic, like what about the junction transistor? Let's know what this B junction transistor and when and where we use it, what the relation between us and this device like that, how the benefit from this device, what the advantage and disadvantage about the BJT, what the better, because we know it has two kinds of BJT. Which one is the better? Which the current is largest in the BJT? And some questions like that, like we will discuss why this type of device has three legs, what that's mean. This another questions. At this lecture, we will try to solve all these important questions. Let's go to the next slide. Let's start from what is the bipolar junction transistor. Let's know what the BJT device. It's a type of transistor that uses both electrons and electron holes. That means it uses two kinds of charge carriers, electrons and electron holes as a charge carriers. BJT is a solid state device, belong to solid state family, in which the current flow between two terminals. Like I said before, it has three terminals. The current will flow between two terminals. This will be the best important terminals to us. The collector is the first one, and the emitter it's be the last one. And between them will be the base. We will explain more information, deeply information about this third legs at the next slides. It is controlled by the amount of current that flows through a third terminal. What the third terminals is the base. That's mean these have strong relation between all of them because the current through flows at the these two terminals has strong related with the base, because at this situation, at this way, we can control, we can focus on the current flows between the terminals, and it's controlled by the base. The base will be the terminal between these two terminals. Let's don't forget that. Now let's answer another question. What is the BJT used for? Now we know it's a solid state device and has three terminals: acceptor, emitter, collector, sorry. And the third one, the last one, is the base, and the base will be between all of them. Now, when and where we use it, bipolar transistors are still used for amplification of signals, switching, and the last thing, in digital circuits. We can say specialized types are used for high voltage switches, for radio frequency amplifiers, and for switching heavy currents. The most important thing to us will be the switch and the amplifier. Now, how can we have of bipolar junction transition? We have two kinds of BJT. The first one, PNP. The second one is NPN. And we will explain the deeper information about them at the next slides. Let's work on, at first, let's take the first version, NPN. What does that mean, NPN of BGD device? After that, we'll talk about PNP. It consists of a layer of P, like here. We have two layers of P from the left side and right side. P-doped semiconductor. Between it consists of a layer of P-doped. Now here we talk about NPN because this version is doped with P-doped semiconductor between two layers of N-doped material. What that means? That means here the base will be the P-type material. That means here the majority will be holes, minority electrons, and the reverse thing with these two sides of N-type material. At PNP, this wafer will doped with N semiconductor at the middle, and P from these two sides. One of them will be emitter, the another will be collector. The same thing here, emitter from this side, collector from this side, and the base terminal will be at the middle. Let's go to the first slide. Why is it called a bipolar transistor? Let's think about that. Let's imagine some idea about why. Because its operation involves two kinds of charge carriers, holes and electrons. That's very important to us because this feature we call to it a bipolar transistor, because the two different kinds of charge carriers at the same time. These are holes and electrons. Note, it's important, I think, since the bipolar transistor was the first transistor invented, when one simplifies transistors, it sometimes means BJT. That means at the same time, we will not say bipolar junction transistors. At the same time, we will say just or another, we will say transistors. That means we suddenly understood that means BJT. Not always use this shortcut, not always use the long name. BJT transistor has three terminals, semiconductor device consisting of two p-n junction which are able to amplify or magnify a signal. The main idea to this device, simply, we will use a small amount of voltage value. And after that, by using this device, we will amplify this signal, this small view of voltage, to a huge number comparing with the first number. It is a current control device, like we said before. A BJT is a type of transistor that uses both electrons and holes as charge carriers. BJT have higher transconductance, which gives them higher gain. Like I said before, we will use small amount of voltage and we will gain a huge amount of this voltage comparing with the first number, which gives them higher gain. They are ideal for amplifiers where you want to maximize the gain. Which current is largest in BJT? Let's thinking about that. Like I said, we have two kinds of BJT, NPN, PNP. And at NPN, at the N terminals, the electrons will be the majority, holes will be the minority. And reverse thing with the base terminal. Now, let's try to answer this question. The common emitter amplifier configuration produces the highest current and potential gain of all the three bipolar transistor configuration. Let us think about that. The current, what is the current, which current is largest in BJT? Here, the emitter amplifier configuration produce the highest current and power gain of the three bipolar transistor configuration. Now we have another questions. This question's talking about what the difference between these two kinds of BJT. An NPN transistor has a base of p-type silicon, like I said before, doped between these two terminals, the collector and the emitter, or we can say the emitter and the collector. Silicon, the base sandwich between two pieces of n-type, the collector and emitter, and PNP transistor, the type of the layers are reversed. That means P is doped between these two emitter and collector. The B will be the base, and from left and right side will be electron are the majority. This is the first difference. Let's talk about the second difference between these two kinds of BJT. NPN and PNP transistor have very similar schematic symbols, but the second difference here is the direction of arrow of the PNP will be going to the inside the circuit, and NPN will be try to go through outside the circuit. Here, this is the base, this is the collector, this is the emitter. The same thing with the PNP. Here, the emitter, the collector, the base. Now, what does bipolar mean in electronics? Let's think about that. In electronics, it's a semiconductor device commonly used for amplification. Like I told before, the most important features in this topic, the switching and the amplify the small amount of voltage, and we can amplify it to a huge number comparing with the first number we started it. The device can amplify analog, or we can say digital signals. It can also switch the DC or function as an oscillator. Physically, we talked about it at the last slide by using the electrons meaning. Now, physically, it is a bipolar transistor amplifiers, the current, but it can be connected in circuit designed to amplify voltage or power. Physically, we can use it to amplify the current, but we can connect it in circuit designed to amplify power or voltage. How bipolar junction transistor can be used as an amplifier. Let's go some deeply to deeply information to can understand how this device can work. A transistor acts as an amplifier by how this device can act like an amplifier. We must raising the strength of weak signal do something like rising, like amplify the signal, the weak signal. The DC bias voltage applied to the emitter bias junction makes it remain in forward bias condition. It's very important. The forward bias condition. The forward, that's mean will make the current through from it. The DC bias voltage applied to the emitter bias from emitter junction makes it remain in forward bias condition. Thus, a small input voltage results in will be a large output voltage. Why? What was the important word? This, it was the important condition to us, the forward bias condition. Without this condition, we can amplify the signal amount of voltage to the large output voltage. So which shows that the transistor works as an amplifier. What are the current carriers in PNP transistor? Current carriers are holes. What is the current carriers in NPN? Will be the electrons. Now, let's wondering about this figure. We have two independent voltage source, like we see here, and two different amount of resistance, and the diode. We connected the diode like that. Why? Let's talking about that. Sorry, let's come back to the last slide. Here, let me put that. I can't move the figure from the side to another side. Here it's some mistake. Let me write it. In NPN transistor, the current passing through the path to the collector have a short lifetime. Let's talk about that. Here, the diodes connected like that. The transistor the current will through passing the path to the collector have a short lifetime. By that, what the most important thing to us by using this connected, hence two diodes connected back to back can never work as transistor. What does mean? That mean will work like amplifier. Here will be the negatively terminal with the negatively terminal, the positively terminal near from the positively terminal of the next diode, and will be this BJT will be we can say NPN. The negative terminal, positive, negative terminal will be because that NPN. Now, what about when we use PNP instead of NPN, and why? Generally, we can use it because the huge similarity between all of them. The PNP transistor can replace NPN transistors in most electronic circuits. What does mean? That's mean not in all the electronic circuits. The only difference is the polarity of the voltage and the direction of the current. The polarity of the voltage and the direction of the current. PNP transistor can also be used as switching devices. Here, like we're seeing here, the emitter P-type, collector P-type, the base is here, the middle is doped by using N-type, and the circuit will be like that. Something like two circuits or two loops, like the Kirchhoff law, say the physicists Kirchhoff law, say, we can say loop one, loop two. This will be the middle wire, acts the base of this BJT. And here, like we say, here, this which of these two kinds of BJT, because the arrow going to inside, that's mean PNP. Here the emitter, here the collector, here the base, and some relation about the current equation between the conductor current, emitter current, something like that. Now let's talk about what are the majority currents carriers in NPN transistor and NPNP transistor. Like we know, in NPN will be the electrons, in PNP will be the holes. Let's talk about what's written here. At the left side, N region emitter, and right side in N region collector, free electrons are the majority carriers and hole are the minority carriers. In P region, holes, majority, electrons, minority. What are the advantages of BJT transistor? Actually has many features because that it's important to us. Let's talk about these features. Smaller mechanical sensitivity, lowest cost. Cost is very important. Here is has lower cost. Similar in size, but especially in small signal circuits, especially in small signal circuits, it's similar in size, low operating voltage for greater safety, low operating voltage for greater safety, tighter clearness, extremely long life. This is important to us. That's mean we will not, that's not necessary to spend more money to buy another devices in short time, lower cost, low operating voltage and greater safety, no power consumption by a cathode heater, that's important, fast switching. All of these are a great advantage. Transistors are also found in bookmarkers, hearing aids, cameras, calculators, and watches. Which is better, PN or PNP? Sure, we're wondering about that. We know now the similarity between them, who is the majority, who is the minority. We know now about most of the important features about this type BJT. Now let's talk what the NPN difference from the PNP. The majority charge carriers in NPN transistor are electrons, like we know. Majority carriers in PNP transistors are holes. The electron, but this is important. We know this information, but let's talk on the next few words. The electrons sure are better carrier charge from the holes, because that what will happen. The NPN will be the favorite type to us when we decided to put it in the electric circuits. NPN transistor are preferred over PNP transistor. Now, how does a PNP bipolar transistor work? Let's focus on this. The PNP transistor is a type of transistor, like we know, in which one N-type materials doped with two P-type materials. All these words are old, but let's focus on the next. It is a device that is controlled by the current. We know that when a small current flow through the base, small current, let me use the mouse sign. When small current will through from the base of the PNP transistor, it turns on. When and where will turn off? The current in PNP transistor, in PNP, I repeat, flows from the emitter here by using this arrow from the emitter to the collector at PNP, and which time will be turned off when small amount of current will flow from the base, and the current at PNP will move from emitter to collector. What is difference between transistor and amplifier? We know it now. The most important things to BJT is the amplifier, and after that we can use it as switch in the electric circuit. But let's know what the difference between the transistor and amplifier. A transistor is a semiconductor component, like we know, and can be used in various different applications. But at first, it's a semiconductor component. It can be used to create amplifiers, but it can also be used as a switch. Amplifier is any device that amplifies the power or voltage of a signal. That's it, without working like switch. This feature makes the transistor better from the amplifier because it has two functions more than the one function about the amplifier. Amplifier can just amplify the signal, power or voltage, but transistor can amplify and can work like switch. How transistor works as a switch? Let's wondering about that. One of the most common uses of transistors in the electric circuit is a simple switch. Let's go deeply to the information. In short, a transistor conducts current across the collector-emitter path only when a voltage is applied to the base. This important condition will be only when a voltage is applied to the bus. What will be the transistor conductor currents across the collector-emitter path when only the voltage is applied to the bus. When no bus voltage is present, the switch will be off. That means here the voltage is controlled on the process, because if we have no bias voltage is present, the switch will off. If we have bias voltage, the switch will be on. The voltage will flow from what? From the bus, the middle terminal between these two legs. This simple circuit image here, this is the BJT, the bipolar transistor, junction transistor. This belong to which one? The narrow going out. I will try to be out the circuit, yes. That's mean it's NPN BJT. Here, the emitter and the collector from the side, the base. Here we connected it with resistance, here from diode. The current will come from here, will be at forward bias. But here we have condition. For example, if we using diode, silicon diode, the VB will be 0.5 to 0.7. If the voltage applied here less than 0.5, nothing will through from the diode. More than 0.5, the diode will be like switch on the short circuit through let the voltage, the current through from it, going to the BJT. And this, we have here another switch. If a switch on, some amount of current or voltage will try to through and will through. If the switch is on, nothing will through and we will be like that. Thank you about listening, your patient. Have a good day and see you at the next interesting topic. Let me stop the recording from here.